Hey guys, welcome back to the channel. This is going to be a short video testing a computer for Brandon Joss. Yeah, he sent me a computer. This is for a 4 Lightning supercharged. Customer concern is the vehicle will crank and crank and no start. It looks like it does not receive the crankshaft and camshaft position sensor signals. I am now duplicating the concern. Let me just make sure I can cover some of his notes in here, but as you can see, that's the B number 326 at the end, 57326. I will show you that I am indeed in communication with it. And I can see right now I'm supplying using the full probe, and I am injecting right now 800 um, RPMs. So through the crankshaft, I have everything connected. I got the diagnostic equipment. For this, I'm using the top-down Max Assist, the Phoenix Max from Top Done, working great. Communication is no problem. I had the 5-volt reference, as you can see right there. Sorry for the glare. And I have just rig camshaft and crankshaft position sensors. These are these two connectors that I have going in here. I still don't have all the spark plugs and injectors because I want to just make sure that I can run. If I receive RPM, which I am not, then I will be diagnosing the computer different. So I have no RPM. I'm going to show you that I am indeed injecting the signal. Before that, I want to go back into 1 second, guys. Sorry, I got interrupted, but yeah, so as you can see, we have communication, and that is the VIN number 57326, as you saw before. But I want to go back, exit the diagnostics. It tells me always to pick up the BCI. I'm going to do the beam scan automatically, and you'll see that we'll pick up pretty fast. I really, really like this tool. Battery is amazing. It lasts, I mean, more than 1 day, which is for us diagnosticians perfect. It has plenty of room for saving the reports and everything. But yeah, that's again the big number right there. We go to quick access. It's going to make a few questions and see what the vehicle is. All right, so always switch the ignition on and everything is on. This is for his records, my records, and also to show how I do it. I will show you in a second all the connections. Right now, all I'm supplying to the module is powers and grounds. And I got a CKP, positive and negative, and then the CMP, which is a square wave signal for uses square wave cam, and then AC signal generator crankshaft position sensor. And the reason that's why we need to use is negative and positive. And I also have two wires that I have going into the meter with the 5-volt reference and the sensor ground to make sure that everything is working. I also have the fuel pump here, and that will come on, and I can do that even though it's going to affect the communication, but you will see this bulb coming on really briefly, and that is the fuel pump relay, which means everything is good. All right, so in here, I will have to, just I know fuel is gas, so that's not a problem. And I think it's also going to ask me if it's a supercharged, and I think this one is from the VIN number. All right, so in here, the only thing that I have right now connected is the PCM. I'm going to need the IC instrument cluster, and that is coming tomorrow to actually run the computer and then have the ignition and injectors. But for those signals that we saw before, I don't really need nothing yet. I can actually try to repair the vehicle and then see if the computer sees RPM. I didn't see anything on the, if I read fault codes, I can just read here. It's probably just going to be for fuel pump P1000 and then the fuel pump driver circuit high and low. This system uses um, two motors on the fuel pump. Let's say that's at least how it shows in the actual wire diagram. But again, if I go over to the data stream, I can select speed, CMP, crankshaft position sensor, make sure there's no errors. although it's still running in here because I didn't give the power to that. So let me actually turn that off, and we can see that it's off. So I'm going to select the camshaft position and status. I'm going to look for, this is the desired RPM, engine revolutions per minute. That's for misfires, misfires. Maybe battery voltage, just to make sure that we are indeed receiving a correct battery voltage. That's right here. And like I said, I was looking for pads or something in here. I don't see that. We can see the fuel pump fault, fuel pump and monitor. O2 sensors, NASI's concerned, so I'm not looking into those, at least not yet. Motor supply voltage. And again, I don't have anything else connected, so for now, this is all we're going to see. But as you can see, I have no pads, and I will probably try to have to go over to the instrument cluster in order to see that. But yeah, so I'm going to turn the um, full probe on and supply RPMs, and we can see have no change. I'm going to connect the oscilloscope 1 second over to the signals like that we can see what I'm supplying in there as well. 1 second. All right, I had 3 channels connected to the signals. Green channel is going to be on this camshaft position sensor. Red and blue are going to be my crank. The red is going to be the positive side, and the blue is going to be the negative side of the sensor. I already set up the oscilloscope, and I changed the trigger to go into channel C, as we can see here. And then these are the signals. As you can see, everything is as it's supposed to be. So the signals are going in inside the computer, and they're just not working. So, or not being sent over to the microprocessor. These computers are very expensive, very hard to find parts. So if you have any of these computers, I'm going to show you the serial. Let me just go around a little bit in here so you guys can see the serial number of this computer. These are the numbers you will be needed: 3L, 3A, and then everything else, and then the NC. These are the numbers, sorry, for this computer. All right, so I'm going to try to do some repairs, replace the AC to DC converter, which is right here. So we got on this computer, this is the AC to DC converter, and the signals are going in through there, and then send it over to the microprocessor, which is in here, right? So we got 2 microprocessors. This is a PCM, so it has engine computer and transmission computer. Then we also have the memory on the bottom. That's the memory for these old style computers. This is still a 2003, but these are used from 1994 up to 2005, I think, and some of the fours, F150s. Not the same serial. You can have pretty much the same numbers, especially the 12A650. That's a very common number on Ford's computers. It's still used still today, and they change the last digits or the front 4 digits. So that's what Ford uses. This is a 104 pin computer. Okay, going on to information. I always do. Let me see. Something got shut down in there, so let me open the actual file. I'm going to go pretty quick in here. Um, these are the pinouts. Not this one. This is a little too blurry. This one. These are the computer pinouts. This is actually the connector, not the computer. This is the connector on the harness, so you will be looking at this backwards. But as you can see, they show you what this all one uh, asterisk to asterisk means, and then all those, because it's very commonly used in all these engines on this specification from Ford. So if it has 2 dots, this means that this will be only for the 4.2 liter. And if it's on the other ones, it's going to be coil and plug 6, because you can see this same cable on the 4.2 will be shift solenoid B, and on these other computers will be coil and plug. So again, you just go through the connectors, through the diagrams, is three connectors, sorry, 3 pages on the same connectors, 104 pins. I'm just going to scroll down slowly so you can guys see. If you need something like this, just let me know. I can help you out with the pinouts and everything. Going on to what I do, I take my time to do my own signals in here. As you can see, these are what I'm going to use at the end for the entire computer. So we have powers and we got grounds. As you can see, I marked 71 and 97 as the same. So these two are the same power, and then 55 is P bad. The grounds 324, 51, and 103, they're all the same. 25 is case ground, and 77 is an extra ground that is not shared compared to these other ones. So these all four grounds in here will be internally interconnected. This is not. I'm not sure yet what it goes to, but if I look into the wire diagrams, which let me open that one second. I got the color of wire diagrams. So if we go over to what was pin 77, yeah. So if we go over to, I'm going to do this pretty quickly because it's pretty easy. But yeah, if we go over to pin 77, you see it says power ground. That's just the way manufacturers use it, and it's supposed to be connected wire harness wise, not internally, with 103. So I don't know why they didn't do that internally, but it's just the way it is. So I'm connected onto those. And for my tested, I'm only using 103 and 77. I don't use case ground because this is to protect the computer. And in the eventuality that you lose one of the grounds for the coils or something like that, and it's not going to damage the computer. Not the case here. But yeah, so these are all the signals that I'm supplying. We got the communications and pins 15 and 16, and then programming on pin 13. And then DLC, these are 13 goes to 13, as communication 16 goes to pin 2 on the DLC, and communication 15 goes to pin 10 on the DLC. So that's pretty much as it goes. Again, CKP is 21 and 22, and camshaft is 85, fuel pump relays 80. And these communications is for me to do my harnesses that I'm also building. As you can see, I'm using this universal test platform. It's really handy. So I'm because if I'm only checking like right now for powers and grounds and communication, I can just plug this in. And if I need a big gun, I can just plug the rest of the harness to that. In this case, I probably shouldn't have not even do that because it's one harness. It's not like two, three connectors like the other computers in four. But I decided to do it like this. It's more like I'm very used to use this one. I like this a lot better than even the communications that has on the full probe. Reason why is because all the pins on the DLC goes through and are complete here. So I can have all the pins from 1 to 16 going onto this connector, not through the full probe. Full probe does not do that, so I will have to run a harness to that connector and then connect it on the back onto these other connections that they have here. So I'm not really too happy about that. And I'm like, you know what? I'd rather have everything nice and secure, no shorts or anything going in through here. But that's how I decided to do it. All right, guys. So pretty much, going pretty quickly. This is what I do with tests on the computer, and we can see that definitely we have no RPM. So his concerns are 100% happening. The computer is healthy. I have communication, I got 5-volt reference, and I have fuel pump prime. The first second the relay activation is right there. So I can then, when I have the computer running, I check for that signal coming back in the computer and computer reading. Because if we see here, it says the fuel pump monitor is on, and it shows us no error. The fuel pump is off because it's off. It's no error because it's not on, right? But yeah, so as far as voltage, everything is good. So I got another computer. This is my computer. This is one of my computers that I have here as a spares in case I need to send, one right away to a customer. It's not for that four F150 Lightning with a supercharge, but it's pretty much the same connector as 104. I want to show you that this is a different serial number, and as you can see, it has my name in there. All right, so this is a YL3F. The other one was a 3 something. And you can see here, if we go over to the big number, it's a 2000, not a 2003. It's an F150 5.4, but not supercharged. And what I want to show you is this. You see how we have RPMs and it's reading RPMs, a camshaft, no camshaft error. I'm doing the same thing. I'm supplying right now 400 RPMs to the computer through, the full probe. And we can see here that the actual fuel pump is cycling the relay. We can see that, how it goes on and off and on and off. And that's what the computer will do in these low RPMs. Let me actually try high RPMs and see what it does. Sometimes it just goes off. Yeah, because you see, the computer does not have the cluster. If I give him too high RPMs, it will not read. So if you give low RPMs, like in this case, the computer will enter in a default of like a cranking condition. And that's what we're seeing in here. It's cranking, cranking. It's trying to uh, see if the key is there or not, but it will let me see that we have indeed communication and the computer is actually alive. Again, just in another computer, so we know for sure that his computer is not working properly. So this is same computer from Brandon Joss. This is whose computer. It's a 2003 SPT Supercharged Lightning. Last 5 digits of the VIN number will be 57326. And this one, for those that haven't seen the first video, his concern was a crank no start condition. Throughout the diagnostic software, the PCM is not seeing a crank or cam signals. Wire for both sensors have been tested without issues. Sensors have both been replaced with no change. I spoke to him and he said that he replaced it with original components. And he said me, I would like to have the PCM tested and if repair possible. I said yes, we can repair it. These are very common concerns and problems with these computers, and it's very, very hard to find parts. And I'm lucky I got a manufacturer or a supplier that I have and can send me all these parts, and that's what I've been done. Well, that's what I've done. All right, so let me finish selecting. This is just pretty much on the last screen. As you can see, that is the correct big number, 57326. Everything is on. Just waiting for, yep, perfect. So read data stream. And as you can see, I haven't still not started a full probe, so we got no signals on cam and crank. Again, I'm just going to select minimum things, camshaft obviously, design RPM, engine RPM, and maybe fuel pump just to see if something is in there. But this is a different system. This computer uses a high and low pressure pumps in the same tank. As far as that's what the wire diagram shows. And what else? Module supply voltage. I don't think there's anything else right that we needed to select in here. Yeah, I don't see nothing else in here. All right, so fill post wet. Obviously, it's nothing going on. So let me start full probe. This will go into quick. Oh, if I turn it on, that would be better. As you can see, I don't know why it does that, but every time I started a full probe, it sends a cam and crank sensor signal. I don't know if it's even the last one it was selected in there, but even I am not sending anything. Obviously, the computer is connected, and this is doing that. So that's something I'm going to probably discuss with them because as soon as I select a vehicle, you'll see that. I'm glad I have the oscilloscope on the back because if as soon as I select this, you see, now it's nothing in there. So, but without anything connected, it's kind of like running a vehicle, and they shouldn't be that way. All right, so let me start this. Select 500 RPMs, and this is great. Look at this. We have RPM. We have RPM. Everything is beautiful, working. This is great, great news. Brandon, this is for your computer. I am very happy. This is definitely 100% fixed. As you can see, we now have engine revolutions. Again, this is your big number. Before we didn't have that. And this is really, really good news. Just going to increase the RPM to see how much the computer actually lets you do. I think it's got to be no more than 750 for the actual RPMs to read, because otherwise it will know this. It's not just cranking. This is like a very low revolution. Since nothing else is connected, I got no math, no nothing. I got to even have 800 RPMs, but I went to zero. You see, it goes in and out, but it's reading. It's reading, and this is great. I am very, very, very happy. This is a very expensive computer. It's in very good shape. It's not nothing that he did. It's just usually the crankshaft position sensor that damages the AC to DC converter. But yep, now it's reading. All right, Brandon. I will be contacting you shortly with the good news, uploading these videos, and sending the computer to you as soon as we receive payment. All right, guys. I think I'm going to put this with the other video, so it's not going to be. I mean, I think it's going to be probably 20 minutes long. Again, that's the AC DC converter, and you always replace that and replace the crystal oscillator next to it, and all these Dells resistors. Those are current sense resistors. You want to replace those. Those are very important for these old computer. Is that also a very common failure that keeps the engine running? So you want to make sure that you replace those if you are trying to do a repair like this. Otherwise, like I said, it's going to be very hard for anything or anybody to repair this. Is a very hard to get or impossible to get component. I'm one of the few that has it, and I'm going to use it for my own customers. I just want to show you, and you can see the new thermal paste. That's a white that is coming in there. You have to separate completely the board in order to work on this. But yeah, everything is good. I'm very, very happy. Very, very happy. All right, guys, I don't want to take more of your time. Thank you so much for visiting the channel. Merry Christmas and a Happy New Year 2022. See you next time. Bye bye.